Okay, so now that we've established or accomplished the difficult task of opening our file in OpenRefine, I want to go through some of the features of this program that really make it helpful for us. So one of the things that we've mentioned and which I highlighted to you all in class, I believe, I think I did this in both sections, is the fact that, as we've been looking to isolate various supermarket chains, we've been doing it primarily by doing a sort, right? We've been looking at the trade name, which appears to correspond pretty sensibly to the idea of a supermarket chain name as we recognize it, and just kind of doing an alphabetical sort and assuming that, everything was sort of well and good with that, and we were getting all of the stores that we needed to. Now, I did find some examples that I think I showed to you where, for example, the store name was not in exactly the same place. A sushi genji at Whole Foods or something like that. And of course, there's also a question there editorially if we think that those things should be included in the same, should be rolled up into Whole Foods or considered separately. But it remains nonetheless that it's important for us to, if we were trying to, for example, compare chains, we would need to make sure that we had all of the chains aggregate. We were able to sort of do a quick count, basically do a count of all the chains. So if we were in a spreadsheet program, we would accomplish this count basically by selecting all of the rows and using the count function to do just that. Google OpenRefine lets us do that kind of task with much greater speed and efficiency, and is one of the things that makes this so strong. So first I want to point out a very mundane distinction, right? Again, I noted in the last video that because we're working in a browser window, in fact, our means of going about sort of simple tasks sometimes get slightly more circuitous in this case. So for example, if I were in Excel and I wanted to copy a column, right, I would just right click and then I would say, copy and then insert, paste or something like that, right? In this case, I need to do a little bit more. So I'm going to open up this context menu here, and I'm going to go to edit column, and I'm going to say add column based on this column. And when I do that, this kind of scary looking window comes up. This window will become more familiar to you, and I promise less scary. And so the primary thing to look at is that it's saying, what is the new column name? So I'm going to call mine chain name. Again, I'm using an underscore to separate two words because I never want to have spaces in column headers if I can possibly avoid it. And then we see, and then it has this thing that says expression value, right? The thing to appreciate right now is that value is the contents of the cell. It is the value that is in that cell. And really, if we look, the main thing to do is to look at our preview, right? So on the left-hand side, it's showing us our original column. On the right-hand side, it's showing us what the contents of our new column will be. And of course, we are just trying to copy the column, so that's all well and good. So I'm just going to hit OK here. And you see it's given me this little yellow confirmation saying, this is what you meant to do it, and it has this weird thing that says grel value, but that will become clearer to us as well. Now, the data file that I'm using is not the edited one. In other words, we have not removed duplicates from this, but for the purposes of this task, that's not important at the moment. Now, what we're going to look at is how we might go about cleaning up these names. Now, the reason why I made this duplicate is because I don't want to lose my original information. I never want to lose my original data, but I do want to be able to create a sort of a column that has the sort of aggregate overview value for the trade name, which is why I've created this chain name one. So one of the most lovely things about OpenRefine is that it provides a tool called faceting. And you'll see it's actually the first option in this context menu here. And because we are working with a text column, as indicated, first of all, by the fact that we see this as text. Secondly, if you note that text is black and this over here, which looks like a number, is green, that means that the program believes that is a number. And I'm going to choose something called text facet. And when I choose text facet, something kind of interesting happens over in this left-hand pane. What you see is this is now provided a sort of what we sometimes call a slice and dice summary of all of the values that appear in that column. Now, this is not a trivial thing. If I were in a spreadsheet program, it's possible that using a filter I could get a similar result, although very often that result can be very difficult to actually export or record because of the way that the filters work. Right off the bat here, I have a pretty valuable set of information, right? I know that there are exactly 250 different chain names or different names in that trade name column. I can see actually in context here, I can see what those options are. I can also see how many times each one of them appears, so I know exactly what the count is. Likewise, I can sort them by count rather than by name, so I can see, again, instantly which one appears the most. And the other thing that I can do is I can use this to create a cross-section, a sort of cross-section view of my database, of my table, right? So for example, let's say I just wanted to see all of the Amish markets. Simply by selecting this, clicking on Amish market, it's going to show me only those rows. And importantly, if you notice up here, it has said 43 matching rows, 2,761 total. Now, of course, this matches the 43 that we see adjacent to Amish market, but the key thing is that we can actually create more than one of these filters at a time. So for now, I'm going to go ahead and go to zip code. We talked about geography as maybe being a significant feature here. Obviously, I don't know. I'm going to do a text facet, even though zip code is a number, because of course we know that a zip code isn't the kind of number you do math on, really, unless you have like a geospatial query, which we're not going to have. So I'm going to actually do a text facet on zip code. And this is the thing that's going to give me some interesting information, right? So now what we see is that within Amish market, that Amish market only exists in two distinct zip codes, right? 10017 and 10019. Now, even within a roughly 3,000 row data set, this is valuable information to be able to get this quickly. I mean, we've had the program open now for all of about 6 minutes. And we could already provide all kinds of sort of summary statistics and overview ideas about, what this operation is, where it exists, and maybe even start to kind of contrast that with other things. So we can apply these as much as we like. We can add as many as we like. If you need more space, you can always just kind of shrink up these windows here. I could look at only the ones that are in this particular zip code and see what that looks like. I know that there are 25. Now, obviously there aren't 25 instances, as we know. In this case, we have duplicates in many cases. And I could also identify that just to confirm. And I would get the fact that, yes, they are all, in fact, the same establishment number. So this is a way that I can provide these very, just sort of cross-section after cross-section after cross-section really, really quickly and really kind of drill down to some of the important information, test out some of my hypotheses, right? If I wanted to do another test, I could, for example, one of the things that we were entertaining, or just one of the things that we mentioned in class is like, well, are there clusters of violations in a particular zip code? So again, if I come back without the restriction on the particular supermarket chain and choose zip code, and I could see by sorting by count, wow, 10019 seems to have a lot of them, right? So when I select this, I now am looking just at the 111 rows. Now if I were to facet, say, by establishment number, I'm going to find out the number of unique stores, right? Because that establishment number is unique. There are only 11 stores, actually, right? And I think this was one of the ones we saw. So the one that has the most is the Morton Williams at 917 9th Avenue, right? So the highest violator in the 10019 zip code in the last 5 years was the Morton Williams at 917 9th Avenue, right? You could see how easily that could become sort of like the lead of a story very, very quickly. But again, there's more that we can do here, even than just looking at our data. And so, as I mentioned at the outset, one of the big things this lets us do is kind of clean up our data in an important way. So I'm going to come back to chain name and do a text facet here. And the text facet is going to show me a bunch of things. So one of the most straightforward opportunities for things that we can do with a text facet is we have this option to do what they call mass editing, right? So normally if I were looking for variations on a name in a spreadsheet program, I would have to do like a find and replace, which is challenging because I don't know what all of the possible values are. So again, huge value in the fact that I get this summary of all of the existing values. And then let's say that I decided, I want it to say A and P, right? That is the chain name that I want to use to kind of roll all of my A and P various kinds up into, right? And so what you see is I can just choose this edit button, right? So that was, I adjusted the first one. And now as I make them the same, it's going to both do the editing. Oops, that's not exactly the same, is it? There's still some white space, gotta watch out for that. Survey says, and you see how it's rolling that up into the A and P category, right? So accomplishing this in a spreadsheet program would actually be really onerous because we would have to go and kind of select each row and, at a certain level, select each row individually for the most part, and then kind of do these edits. So this is a pretty good, this is a pretty handy thing, particularly if you only have a couple of variations or small variations in the names. You don't have too much work to do. Now, of course, we realize that this isn't always the case, and we will see this in our next edition, right? So it's okay if we have 5 or 6 rows, we can kind of go in there by hand. But what about a case like this? Okay, we're seeing associated. It's 10, it's 15, it's not too many, but it's kind of a lot. We get into C-Town, that's not so good looking, right? We can see Food Emporium, right? We could see we would have to do this kind of, it's still kind of manual, this editing, right? It's still a little bit time consuming. So this now highlights, again, one of the enormously valuable features, which is the cluster feature. So when I choose cluster, we're not going to go into how these algorithms work because frankly it's not really important. There's very limited opportunity to modify them and optimize them. So what we're going to recommend is that in general, if you think you need a clustering algorithm, come in here and start clicking around and see what you get. But key collision is the default. And it's the keying function, essentially the algorithm it's using is fingerprint. And what you can do is just kind of like select down here and start playing, with these values. I think n-gram size probably when it's lower, more gets together. So actually when I go to n-gram size 1, I actually get some decent stuff, right? I could now cluster these Pioneer supermarkets and associated 785 and 857. I'm actually going to keep going because I want something a little bit more powerful. Metaphone is actually exactly what it sounds like. What does the word, it's exactly what it sounds like. It is reflecting what the words sound like. So in this case, like I can choose this one and say, I want to merge all of these values into key food. And I get a lot of stuff that I would otherwise have to do 10 rows, 15 rows, right? I would have to edit all of these by hand, even in that mass editing window, if I didn't have this. And so I can just choose Merge Selected and Recluster. And of course, I could have done more in that, right? But again, I can say, okay, that's right. I want all of these to just be Gristedes. Cluster, 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 right? Western beef. So you can see how unbelievably powerful this is just in getting kind of everything together, so that I can get that overview of my data in a much cleaner and more straightforward fashion. So I'm not going to go through all of this, but I think you guys get the idea. So again, hugely valuable feature of this program. And when we come back, we're going to look at a couple of other things that it does, specifically with regard to documentation, which I know has been a sticking point for some of you, and this is actually going to help you out with that too, as well as the replicability and transferability of your work. So we will see you back here in a few minutes.